Small basic ideas. Now the applied force is, say, let it be 12 Newton. That the same values, m equal to 2 kg. Mu s 0.5. And the values will be same, no? Fl equal to mu s n mu s mg 10 Newton. What is Fk? Mu k n 4 Newton. And the block, I'll give velocity u equal to all the values same. Only thing is the applied force, I'll make it. This is what? T equal to 0. Normal reaction. This is the weight. Tell me, like, what should happen now? Here the applied force is greater than limiting friction. So block will move towards left. No, you look at the kinematics. The friction, the displacement of block is towards right. The friction will act to oppose relative motion. What friction will act? Kinetic. Then what is the acceleration? Acceleration of the block equal to F plus Fk by m. Or it's a retardation. 12 plus 4 by 2. 16, 8 meters per second square. That will be the retardation. Then the block will undergo retardation and it will come to rest. When do it will come to rest? 0 equal to u minus 80. 0 is 6. This will be 8. So t equal to 3 by 4 seconds. It will come to rest. So the moment it comes to rest, tell me what will happen now. So in between, what are the conditions that will arise? The block will have velocity. It will have retardation, the applied force, and this is a kinetic friction. Then the moment block comes to rest, tell me what conditions will arise. Applied force, a constant. Force of F equal to 12 Newton acts on block. Okay, that's the basic condition. And now the moment it comes to rest, at what? T equal to 3 by 4 seconds. Just it come to rest here. Tell me, like, how the direction of friction I have to show it. Just less than 3 by 4. 3 by 4, anybody value? 0.725 seconds.
7.5.
7.5. 0.74 seconds. How the friction will be acting? Will be like this only. Clear this one? And it will have some velocity, v dash. And next again, at t equal to more than 0.76, I'll write it. At t equal to tell me, anybody, how the direction of friction should be? Should be towards right, no? And now, sir, why not static friction? Look at the applied force greater than limiting. At t equal to 0.75, it will come to instantaneous rest.
Sir,
Now what will happen to block? Block will accelerate towards left. Yeah.
sir, at that instantaneous rest, what will be the friction, sir? Will it be
The
Fs
friction, the friction has to change the direction. For it to change direction, what happen? The friction, like it has to become 0, then it will become Fk. So that particular thing, practically, it's very difficult to analyze.
So, sir, at 3 by 4 seconds, we can't tell the direction of F, sir.
The moment it comes to rest, there's no relative motion, no? When the friction will act, relative motion, and the force 12 Newton is acting. So the friction will act. So what actually happens here? the kinetic friction, from kinetic friction, what happens, the moment it comes to rest, the kinetic friction should vanish. You see what all happens here. The kinetic friction will vanish. Means the moment it comes to rest, no relative motion. At one instant, it will be at rest, no? Okay, got this? So therefore, kinetic friction will vanish. Then again, the block starts moving. The block starts moving means I applied a 12 Newton. So what will happen? Suddenly the friction will happen. The block starts moving. So 12 Newton force is continuously acting. So therefore the friction will happen. Suddenly from static will become kinetic. So there's everything occurs in that interval of time. Got the idea? The kinetic friction will become zero. Then what will happen? Then the 12 Newton force is acting. So the applied force is greater than the limiting friction. The block starts moving. So there'll be relative motion, then kinetic friction will come. But what about any static? As the friction will happen, suddenly cannot be kinetic. But practically we do neglect that static friction acting for small duration because the time interval will be 0.00001 second. So we need to bother, just leave it. So that's why I'm just showing only kinetic here. You need to bother because we don't have any mathematics to analyze anything in detail at that interval. It's of no use to anybody also. So just bother about at that instant what happened, the friction should vanish here. And very next instant what happened, it should vanish. So that time interval is so small, no? Practically we can't measure also any parameters. Okay, no, I think there's nothing called like any golden rule. Sir, you give formula, I'll apply, I'll get the direction of friction. So we should really analyze all the situations, no? Yeah. We should look at the velocity of the block. We should look at the applied force. We should look at the direction of force. We should look at even the